Welcome to Algebra 1, Semester 1, Unit 2, Final Exam Review. I just wanted to run through this fairly quick for you here. Remember, if you're trying to learn the topics, you should be going to the notes, the actual notes sections on these topics. But if you're reviewing and wanting to learn the test-taking skills for the final exam and look more specifically at the type of situations I'm going to put you through on the final, then this is the place to be. Okay, this is Unit 2. So the very first problem here, I just want to show you how I would read through it. Hopefully you're on a device where you can enlarge sometimes when you need to. I'll try to watch this a little bit. Okay, so in this first one, you're at an apple orchard. Allows people to pick their own apples. Customers pay $5 for a basket. So let's think about that. If you go in and you just get a basket, you're going to pay $5 right off the bat. No apple whatsoever. Then they get charged 10 cents for each apple. So if you pick one apple, your total price would be $5.10. You pick two apples, $5.20. And so on and so forth. That's all that they want you to do is find the range of the function. Range of the function means what's your total cost. You can plug your scenarios right in there if you want to plug it in. I just kind of think through the storyline of what's happening. So that would tell you D is correct. C, I'd want you to mark that you can't have 0 because the basket costs. Here they're saying the basket doesn't cost, so that's why that one's out. Here they don't take into account that the apples are 10 cents. Apples, 10 cents. They're going with full dollars. Those are spendy apples. And then real numbers includes negative. Don't think we're going to have negative numbers in this one, guys. So that one's out. Okay, remember on the test, you've got to show all your work explaining why you picked the one that you picked. Okay, on the next one, a point. Remember, points are x and y on the graph. Has an ordered pair of negative 12, 9. They want to know what is the n value, the y value, if you plug this negative 12 in for x. So you would literally just take this and you can write it on your own whiteboard, or you can use whiteboards during the test, or you can write it on a piece of scratch paper. You just plug, you just plug negative 12 in for the x. 3 times negative 12 minus 9. 3 times negative 12 is negative 36 minus 9. Signs are the same, you just add them together. That would be a negative 45 for your f of x, which is also your y value, which is also your n value. Okay, so a negative 45 there. If you show all that work, then on this type of a problem, there would be no need to be marking anything else. Just double check that it's exactly the answer that you have. Number 15, which properties would transform this? I would actually write this out and think about your properties. All of you guys became excellent at properties. And so I just want to emphasize, look at the different halves of the problem. I'm so sorry I've got my arm through the tripod, so I keep hitting that. Look at the different halves of the problem. Just cover up the other half. What property are you using to get from there to there? Well, we end up wiping away the parentheses. And I hope you remember doing this for this property. If you said distributive, you're exactly right. So when you use the distributive property, now if you look at your answer options, you can mark out 2 options. Remember, I want you to practice elimination on this test. 2 options don't even have distributive, so get that one out of there, that one out of there, because these properties are not distributive. Now, they could have had distributed over here, that would have been fine, but they don't have it at all. Okay, so the next thing is to look at the other half of the equation. What is that property called? Whoa, I'm sorry, just now looked at my monitor trying to put this in here. Okay, what is that property called when we move the terms, rearrange them? We put the 7x in front, the 10 behind. Hopefully you're remembering, we move within our community. So that would be the commutative property. Because you've eliminated two answer options, you can see this is addition property of equality. If you didn't remember the name commutative, maybe you'd remember addition property means you're adding to each side. Here's the commutative, distributive, there's your answer. Okay, next problem. It says, what is the solution? Well, this is one of those where you actually need to draw the line and gather all your creepy dudes together. Remember, when we have a lot of creepy dudes on this teeter-totter, we don't want them scattered about. We want to get them together. So let's rearrange it using the commutative property so that we have those two in the same area. That would be 5x plus 2x would be 7x minus 2 equals 7x minus 2. We need to move these over to here. Subtraction property of equality. That wipes that x term completely out. We have negative 2 equals negative 2. That means that no matter what you put in for the x value, you will always come out with a true statement. Because it is true, it means that you have infinite solutions. Any number you choose to put in there will create a true solution, okay? If it came out where it was not equal, then that would be no solution. It would never work. So that is infinite solutions. On the last one there, what is the solution for x in this equation? This one usually stresses people out because it's got fractions in it, okay? Don't get stressed out over fractions. Just ask yourself, what number will all of these numbers go into? And you can multiply by that number to cancel the fractions out. So we take 8 and 12 and 4. We think, what are the multiples? You could go through the multiples and list it. You'd find that each of them goes into 24. That's the lowest number that I'll go into. So we're going to multiply this by 24, this by 24, and this by 24. What that does is it cancels our fractions out. 8 will go into 24 3 times, so now we have 3 times 3x. 12 will go into 24 2 times, so we have minus 2 times 1. And 4 will go into 24 6 times, so we now have a negative 6 times 3. Go ahead and multiply those. 3 times 3 is 9x, minus 2 times 1 is 2, equals negative 18. Now you're clear to the point of just solving. Draw the line, write your PIMDAs, arrow going up, and you are going to circle this creepy dude. That's who you're trying to get alone. So you ask yourself, what's being added or subtracted on his side of the teeter-totter? You see that negative 2, it's being subtracted. Mark out subtract. That means you add. So we add 2 to each side. Addition property of equality right there. Okay? That cancels. We get 9x equals, well, we have a negative 18 and a positive 2. Different signs, we find a difference. Negative 16. Now we need to get rid of this 9 being with the x. We want him all by himself. We're up to the level of multiply divide. 9 setting right next to the variable means it's being multiplied, so that shows us to divide. Divide by 9, divide by 9. We find our answer is negative 16 ninths. If you show all that work, there's no need to try to justify why the other answers are incorrect. Just circle the correct one and show me all that work. Okay? Next page. Again, you should be pausing. I've just got to hurry through so that it uploads fairly quickly. Again, we're going to solve for x. So the same procedure as before. I'd pause the video on this one and see if you can get it without my help. And then come back on and check your answer. On this one, I'd use commutative property to get my x's together. So I have negative 3x plus 25 plus 21 equals 2. Negative 3x plus x would be negative 2x. Different signs, find the difference. Same signs, add them together and give them the same sign. So 21 and 25 would be 46 equals 2. We subtract 46 from each side because at this point we're going up the PIMDAs. And we're asking ourselves what's being added or subtracted to the x, or the creepy dude that we circled. And it is plus 46, so we do the opposite, minus 46. What we do to one side, we do to the other. Those cancel, we get negative 2x equals negative and a positive. Different signs, we find the difference. Negative 44, divide by negative 2, and we get x equals a positive 22. Okay? Now, another way that you could go about this, in case you forgot how to do all that, you could take this, the numbers, and actually plug them in for the x value, and it should come out true. That's not my preferred way, but hey, when you're on tests, I will give you points for any method of survival and showing me that you can do the math. Whether it's how I'm really leaning you into doing it or not, I will give you some credit for that. Okay, on this one, we have another situation where we're trying to solve for x. And before we go to the PIMDAs, try to fit that on there. Sorry about my screen. Okay, before we go to the PIMDAs with this, we need to distribute, get rid of our parentheses. So we have 34.8x plus 0.2x. 0.2 times negative 4, you can work that on a calculator if you need to. A negative times a positive is negative. 4 times 2 is 8. Bring in the one decimal place. So that's 0.8 equals negative 16.8 plus 27x. Circle our x's. We need to gather those together. Okay? So let's get these two gathered together. 34.8 and 0.2. We just put them together. It's 35x minus 0.8 equals negative 16.8 plus 27x. We want to get this x over here with this one. Get rid of it over here. It's a positive. We want to move the whole thing. Don't try to divide there. You don't want to leave them there and split them up. You want to bring the whole thing over here. So that cancels. 35 minus 27 would be 8x minus 0.8 equals negative 16.8. Now you're at the point where you've got one spotlight on one creepy dude, and we can write the PIMDAs. Going up the PIMDAs, what's being added or subtracted to the creepy dude? It's a negative 0.8, so put a positive 0.8. These wipe out, we get 8x. And nice thing here is, opposite signs we subtract, the 8's cancel out, and we just get negative 16. Divide by 8 on each side, x equals negative 2. So we go to our test, and we should find negative 2. It's negative 2.0, that'll work. If you want to verify that it's correct, you could plug it in for the x value. Okay, I'll bring this in a little bit closer to the next one. I want to work on the actual test here, let you see it. what I'm thinking here. Which of the following could be the first step in solving the equation? Okay, well, we need to think of options. And in class, I tried to have you work with partners, and we tried to look at options of how people would solve things. So just think about us being in discussion, and somebody says, hey, can we subtract 3? Well, hopefully you remember, we can't go inside the parentheses until we're clear up at the top of our ladder. We have a lot of stuff to do outside parentheses before we can get up here and go inside the parentheses. So if it says subtract 3 from both sides of the equation, hopefully you go, oh, that looks strange. No, I'm not doing that. Okay. Could we distribute 1/2? Well, that's what you guys normally do, is when you've got a parentheses, get rid of the parentheses, we do distribute. So that one would be good. How about if we multiply by the reciprocal of 1/2? We have done that a few times in class. When people see the 1/2 setting out there in front, they say, let's get rid of it. And what they do on one side, they have to do on the other, because they're introducing another number into the problem. So to keep it equal, you have to do it on both sides. So that would work. That would cancel that out, and you'd go on with the equation. So 1 and 3 work. Now at this point, you could stop and go to your answers. All of the above, we know that 2 doesn't work, so that's out. 1 and 5, well, we know that 3 does work, so that one's out. 1, 3, and 4, that might be our ticket because it's got 1 and 3. 1 and 4, that doesn't contain 3. So let's just look at number 4 and make sure it looks good. Could we divide 1 by 1/2 on both sides? 1/2 is being multiplied in the original problem, so you could divide to get rid of that. I know it doesn't look happy, but we could do it. So that'll work. Always use your test-taking skills to eliminate wrong answers. In math, that just helps you so much. Okay. Student wants to solve this problem. There's the original problem. And it says, student steps are shown below. Which properties justify the missing steps? I love giving you guys this one because all of you became experts with properties. So, main thing that I would say is, as you're doing this test, if you have the opportunity to use a highlighter, or in some way you can kind of, if colors help you, highlight what's different from one to the next. You're adding a 2x on each side. If we add something to both sides of the equation, that's the addition property of, it's an inequality, so inequality. Okay, we come down to our answers. You can already eliminate 2. That's so common in math class. Summation, summation, no, we call it addition property of equality, inequality. So the next thing, we look at this. Subtraction property is the same on both. It's not until the 6th step we need to know if it's multiplication or division. We come up, we can see here where we subtracted 7 on both sides, so that is the subtraction property of inequality, sorry. And if you look at the next thing, you're at 6 is less than 2x, and we divide by 2 on each side. So that would be the division property of inequality. So we come down, it's not multiplication, that's what's wrong on that one. It is this one. Whoops, mark that one out. Okay? Sorry, I went a little bit off the screen. Okay, last one here. Which of the following inequalities represents 3a minus, oh well, this one's pretty easy to do like you've been doing the others. Actually go in and just solve it. Again, you can always work backwards, plug the values in, and see what works. It just oftentimes takes longer. We draw the line down. Now notice, our creepy dude is all on the same side of the teeter-totter. Just move them around and put them together. 3a minus 6a plus 3 is 15. Hopefully you remember that's commutative property of inequality. Actually, not of inequality, just commutative property. Okay, 3a minus 6a, they're different signs. Find the difference. That would be 3. The one farthest from 0 is a negative, so give it a negative 3a. Plus 3 is greater than 15. Now, we want to get the a alone. We go up our PIMDAs. 3 is being added, so we need to subtract 3. That'll cancel. We get negative 3a is greater than 12. Here's the tricky part of the problem. There's always something that you want to be aware of, and that is that we need to divide now by the negative. When you divide an inequality by a negative, remember our proofs in class, it flips that inequality sign. Okay? So we have a is less than negative 4. We go to the test, and we find a lot of options here. Be really careful which one you choose. See how you've got 2 of them with negative 4s? This one's got a positive 4. That one's out. This one was completely out. Go over to these and match it exactly to your answer. It says less than. You want to make sure you get the less than. This one has a greater than. That's why it's out. Okay, next page. Again, you can be pausing. I'm just trying to get through these. I've got students waiting to be tutored, and then I also need to upload fairly quick on this one. This is a complex inequality. As soon as you see this problem, I want you to go straight down to the graph. You know, with complex inequalities, you only have 2 options for a graph. If it's an or, it goes out like a seal, or if it doesn't have the or, you keep it like a hug. This means solid circle, it can equal it. This means open circle, and we connect them. Now, to do the problem, you have 2 teeter-totter lines now. Simply go up your PIMDAs, circling the creepy dude, and saying, what is added or subtracted to him? He's got the spotlight. He's the one that's kind of creeping us out. We need to keep our eye on him. So if he's got a minus, that tells us to add that. Okay, 14 plus 7 is 21. 7x. 42 plus 7, 49. Okay, now we look at the next part. 7x. It's being multiplied because it's sitting right next to it. So we want to divide. Make sure you divide over here. This is the most common error, not to divide that one. And divide over there. 21 divided by 7 is 3. 49 divided by 7 is 7. So we get 3 is less than or equal to x, because that canceled, which is less than 7. Okay? So on your test, you look for that answer. It was 3 and 7. If you're showing me all the work, like I've just shown you, you don't need to show me what's wrong with these others. Just make sure to read them carefully. Okay, the student solved the inequality where x is shown below. Is the student correct? Explain. Well, let's see what he did. He's solving for x. He's going up the PIMDAs. And his first question is, what's being added or subtracted to the x? 5 is being added, so he brought in a minus 5. That cancels, and we get xy. This, negative 2 and negative 5, makes negative 7. Now, he's still got this creepy dude of an x. He's done with add, subtract. He's on multiply, divide. X is being multiplied by y, so we divide each side by y. That cancels that, and we get x is less than or equal to w minus 7 over y. This would be correct. So down here, we don't see any errors. We need to mark out no, because we do think that he's correct. Now it says, yes, the solution is correct if y is a negative integer. Ooh, let's think about it. If y was negative and we divided right here by a negative number, what would we have to do to the inequality? We'd have to flip it just like on that last problem. So it's not correct if y was negative. Yes, the solution is correct if it's positive. There we go. Really watch these answers, really compare what they mean. Okay, now we come to another complex inequality. This one has the or. Remember back when I taught you that? We talked about the two kinds of graphs. It's a hug, or it is like the seal saying or. And I made you put your hands out. This one points this way. This one points this way. This one has a closed circle. This one has an open circle. Well, how many of our graphs even accommodate that? This one is absolutely wrong. It's a connected hug. This one is a hug. Wow, we've got two of them out of there. This one would work, and this one would work. The only difference that I see in this is that this has an answer of -2. This has an answer of 1/2. This has an answer of 4. This has an answer of 3. So let's find the answer at least to one of these. We wouldn't need to solve both. Let's just solve one. Just like you've been doing this whole test, draw the line. Circle the creepy dude, write the PIMDAs. We're going up the PIMDAs. What's being added or subtracted? 5 is being added. So we subtract 5 from each side. That cancels, we get 2x is less than -4. Done with add, subtract. 2 is multiplied by the x, so we divide by 2. We get x is less than -2. That means the graph that I pointed out just a minute ago, where I said it was x is less than -2, is the correct graph right there. This one, what's wrong with it, is the location of that. Okay, and if you've shown your work, you've got the credit for it. Okay, suppose a is less than 10, which of the following must be true? Let's think of some numbers less than 10. Let's think -10, let's think 0, and let's think 9. Okay, if I have a -10 for a, and I plug it in, that would be a negative 10 is greater than 10. Two negatives make a positive. Is 10 greater than 10? No, that one's out. Okay, if I go here with a -10, -10 would be less than 9. Would 9 be less than or equal to 9? 0, less than or equal to 9. That one's a possibility. Okay, could be. Let's try here. If we plug in 9, let's say 3 times 9 is 27, plus 7, that would be 34. That would work. I apologize on the phone. This one could work too. Let's plug in a -10 here. -10 absolute value would not be true because an absolute value of -10 would become +10, and 10 is not less than 10, so we mark that one out. We are down to these two options. A is less than 10, which must be true. I'm just going to show you how I'd do this on a test. I'd probably solve for A here. 3a plus 7 less than 40. Draw my line, subtract 7, and I would get 3a is less than 40 minus 7 would be 33. Divide by 3. A is less than 11 here. So we could actually use the value of 10, a positive 10 here, and it would still be true, and it's not true there. It's not necessarily true there. So I'm going to go with B. I hope that that's right. Okay. Here we go. Almost done. I apologize, that last one I didn't look at real closely to make sure that it's right, because I'm trying to rush. I gotta back up and show you the mistake that I made. On this one, it says that A is less than 9. We did make an error. A is less than 9, but this is saying A is less than 10. So if we did 9.5 for A, if A was equal to 9.5, this one would be true, but this one is not true. So that's how come that one falters. This one, if A is less than 10, it will also be less than 11. So we can draw that one in too. Okay, come see me on that one. I kind of rushed through it. Didn't catch on to what I was showing you in that one. Okay. Sean is driving to visit a friend. And I would suggest drawing this one out, definitely. Basically, it says the first hour he goes 1/5 of the distance, then he goes 34 miles in the next hour, 194 in the next. And it asks, well, how far do they live apart? If this is 1/5, this would be 4/5 over here, because the whole distance is going to be 5/5. Okay, so if we know that the distance is 5 parts, total distance is 5 parts, and 4 parts is this distance, we can add those together. 4 and 4 is 8, 3 and 9 is 12, 1 and 1 is 2, and we get a proportion. At this point, you can either cross multiply, or you can divide 4 into 228. It would go in there 57 times, and multiply 5 by 57. And that'll tell you your total distance. Okay, you can do it either way. Cross multiplying is multiplying that and then dividing by the 4. So you'd have 5 times 228 equals 4 times x, and then divide by 4. Okay, either way will work, but that's what that problem looks like. Make sure and look back over that one to make sure that you get the final answer. The final answer is the 285. That's what you should have. If not, come see me. Okay. Next one is they're wanting to know if you're charged $8.50 for an adult ticket to go into a theater, and you have a reduced price of 50 cents for every can of food that you bring. Which of the equations represents this? Best way to do that is on a T-chart. You guys got so good with T-charts. So if we have 0, our price would be $8.50. Remember, the 0 column is the one that shows you how much to add. Okay, if you have 1 can, then they're going to subtract 50 cents, aren't they? So we go with $8.50 minus 0.5 times your 1, or 0.50 times 1, which would be $8. 2 cans. $8.50 minus 50 cents times 2. 2 times 50 cents is $1, so that would come out at $7.50. Now, if you remember from when we played the Funchkin Munchkin game, these are your variables. The number of cans are the variables, that's your x. So you'd have x sitting next to your negative 0.50. We can use the commutative property, turn that around so it's 850 minus 0.50x, just like we did in the actual problem, or we can have it that way. Let's look at what our answers look like. Look closely at these. This one has a plus 0.50x, so that one's out. This has a negative 9, we don't even go there. This one has 9, that's another one we don't go to, so that's the only other close one. Okay, next problem. Got a scenario here where you've got 15 members. Make sure to underline important information. And you're going to buy t-shirts for them. You've got $135 to spend. It's going to cost you $45 for the design. So first thing I'd do is take $135 and I'd subtract out $45 for the design and say, how much money do I really have to spend on each shirt? So $90. So what we're saying is that 15 times whatever type shirt you get needs to be less than or equal to the 90. All you do is divide by 15, and you would find that x has to be less than or equal to 6. So you could buy any of those. You couldn't do the sweatshirt. Okay? Interesting thing here. You could also work it this way. You could actually go through it and take 15 times each of these, add the 45, and make sure that it's less than 135. Just show all of your work. Okay? Since we know the sweatshirt's out, that makes A out, that makes C out. And you could have almost done this without doing the math, because it would make sense that you couldn't order a long sleeve, or you couldn't do long sleeve without the other two cheaper ones. So that one would be out just off of logic as well. But I want you to show some kind of work. Explain your logic if you're doing it that way. Last problem here for the night. Last problem is we want to get y squared by itself. So we have m equals y squared minus y1 over x2 minus x1. I'm sorry, that's not y squared. It's just y2. We want to get the y2 by itself. To get rid of this, it's being divided. You want to do the opposite, put it in parentheses. x2 minus x1, what you do to one side of the equation, do to the other, squeeze it in here next to the m, so m times x2 minus x1 equals y2 minus y1. Now you might say, why couldn't we added that y1 before we multiplied? It's because when we're in fraction form, it's considered that they're inside parentheses. Okay, so now we can add the y1. So we get y1 plus m times x2 minus x1. Again, I apologize, I'm rushing a little bit. This has gotten erased a couple times, and I'm just trying to get it online for you tonight. So when you look for this one, it is A. Come see me if you need me to explain that one. Come see me before class. Have a good night. Good luck studying.